Since the 1970s, we have been sending special landers and surveyors to Mars to check its terrain and what elements are on the surface, and if there is water in there. Although Mars is just half the size of the Earth, it has enough similarities to make it appealing for human exploration. However, it has enough differences to make the dream of moving to Mars impossible unless we develop the right technology and the planet has the necessary elements to support a civilization like ours. NASA Mars Global Surveyor, NASA Mars Odyssey, and the Mars Express developed by the European Space Agency are three missions that had been or are currently studying the red planet. The Mars orbiters continuously survey the surface of the planet, sending spectacular images that answer many questions about our neighbor. For example, images taken by the Mars Global Surveyor reveal that the planetarium, the Martian North Pole, is covered in layers and layers of fine dust and water ice several kilometers thick. It has a permanent ice cap fixture approximately 621 miles across that during the summer months is mainly water ice, but during the winter it grows by almost 6.5 feet when about 30% of the carbon dioxide in the planet's atmosphere freezes and falls down the polar caps. In the North Pole, there is also a very interesting prominent dark feature that seems to cut the region in two. This is the Chasma Borealis that is approximately 1.2 miles thick and 155 miles across. This is thought to be a relatively old feature that formed before the ice dust spiral features that we see in the North Pole of Mars, and probably is growing in depth as new ice deposits build up around it. Studying this feature has been very important to understand how the dust and ice layers near the Mars surface. The ice with a spiral-like shape in the Martian North Pole is most likely the result of the strong winds that blow from the elevated center toward its lower edges by the same Coriolis force that causes hurricanes to spiral on Earth, shaping the ice cap over time. On the other hand, ESA Mars Express reveals a top view of the dust layers, water ice, and frost that is covering a region that is beyond the planetarium in the surroundings. For example, a subtle wrinkle in the surface here indicates where layers of materials are starting to build up next to these very starkly cliffs of miles across that are covered in frost and ice walls. If we look beyond the poles, Mars now appears to be an arid world. However, the planet's surface is rich with signs that water was once abundant. What is this water? The answer was confirmed conclusively by one mission, the NASA Phoenix Mars lander, which collected a soil sample containing water ice from the polar region on July 31, 2008. This discovery was important because at the temperatures near the equator, which are not cold enough, exposed water ice will evaporate and escape the atmosphere. So if there is water in this region, it's way down the surface. To check this, the Mars Express mission surveyor used radio signal to study the equatorial region called Medusae Fossae Formation, revealing massive deposit of this vital element on the ground up to 1.5 miles deep. Most recent observations suggest that Mars has layers of dust and ice 2.3 miles thick, all topped by a protective layer of dry dust and ash several hundred meters thick. From these findings, the Mars Express team concludes that the entire planet is covered in a layer of water 5 to 9 feet deep, the most water ever found in this part of Mars, and enough to fill Earth's Red Sea. On the other side of the planet, the ESA Rococosmos ExoMars Trace Gas Orbiter studied the heart of the Mars Canyon system called Valle Marineris. It used the fine-resolution epithermal neutron detector to map the hydrogen, which is a measure of water content in the uppermost meter of Mars soil. The conclusion again was that there is a central part of Valle Marineris packed full of water, far more water than expected. And in an independent test by ERISI, a camera on board of NASA Mars Reconnaissance Orbiter, observed the locations of ice exposing meteoroid impacts and showed the likely distribution of water ice buried within the upper 3 feet of the planet's surface. So, with all this information, scientists can now decide where the first astronauts on Mars should land. The most important factor is to find regions where astronauts can find water ice to convert into drinking water and to use as an ingredient for rocket fuel. This, however, had to be far from the Mars poles where, although there is plenty of ice, the temperatures are too cold for astronauts or even robots to survive for long. So after hearing all this, are you ready for a trip to Mars to go there and colonize?